Good evening students. In today's class we will discuss about organic chemistry equations. First one is alkanes. Laboratory preparation. Always remember we will study the equations in terms of reagents. So understand that soda lime helps in the process of decarboxylation. What is meant by soda lime? Soda lime is NaOH. So in the presence of calcium oxide you have to heat that. What is the role of calcium oxide? So it helps NaOH not to absorb moisture. Okay, so generally you know that NaOH will absorb moisture from the atmosphere. In the presence of calcium oxide, NaOH does not melt. That is the purpose of CaO. Now what is meant by decarboxylation? D means removal. So removal of carbon dioxide in the form of Na2CO3 is known as decarboxylation reaction, and in that soda lime is the reagent. Next, with the equation, if you take CH3COO nothing but sodium acetate. So sodium acetate if you take, and how the decarboxylation occurs in presence of NaOH and calcium oxide, you heat this. So remove sodium carbonate from here like this. So here it is Na2 and this is CO2 and one oxygen. So we are removing carbon dioxide in the form of sodium carbonate. Next, what is left out? This side CH3, here H, so methane is obtained. So this is the preparation of methane. Now next, if you increase the number of carbons like this, so that is CH3, CH2, COO, Na, and again soda lime is added. On heating, what happens? Will remove sodium carbonate like this. So this is decarboxylation. What is obtained now? Apart from Na2CO3, you got CH3CH2 here and one hydrogen is present, so we can write it as CH3CH3. So we have ethane, and in the first reaction we got a methane. So if you take sodium acetate, product is methane, right? Are you able to understand? So hope you have got this first decarboxylation reaction. Next, some other properties are given, that is from iodomethane. Second one, if you take iodomethane. So what is iodomethane? It is nothing but CH3I. So reduction, you want to add hydrogen to this. Okay, so when you will add hydrogen like this, these are called as nascent hydrogens, and nascent hydrogens are added when you use you can use lithium aluminum hydride reducing agent, otherwise you can add sodium borohydride. So they give 4 nascent hydrogens. In this condition, what will happen? You can expand this and write like this is CH3, right? So we have to add hydrogens. So one H is added to this and another H is added to I. So what we get? We get methane plus HI. Right, hope you have understood this. Next, they have given Wood's reaction. What is meant by Wood's reaction? Wood's reaction is nothing but if you take alkyl halide Rx plus sodium and one more Rx like this. So this is nothing but alkyl halide in the presence of sodium, and the solvent should be dry ether. Then what will happen? We will remove Na2X like this. So we can take R, write 2NaX plus R dash R. So we can synthesize alkanes. Now first and foremost thing, we take methyl iodide plus 2Na and another molecule of methyl iodide. So solvent should be always dry ether because sodium should not absorb moisture. So in this method we can remove 2NaI and the product obtained is CH3-CH3. So we get ethane in the process of Wood's reaction. Methane cannot be synthesized in this method. Okay, hope you have understood this. So this is about Wood's reaction. Next one is about complete combustion of alkane. Any alkane, let them give. So how do you perform this combustion? First take methane. Methane plus O2. Always remember, carbon gives carbon dioxide and hydrogen will give H2O in the combustion. Now for balancing the equation, you have to follow the order of carbon, hydrogen and oxygen. First observe carbon, you have 1, so therefore write coefficient 1 here. Next hydrogen are 4, so we have to mention 2 water molecules. After that count the oxygens, here 2 and here 2, totally 4, so coefficient 2 should be written on the left hand side. So this is about your combustion reaction. Suppose ethane is there, C2H6 plus O2 on heating will give carbon dioxide plus water. Once again you have to follow the order of CHO. Carbon 2, so write coefficient 2 here. Then 6 hydrogens, write 3 here. Next oxygen you count 4 plus 3, 7. If there is odd number, immediately take it as 7 by 2, because 7 is odd number, you have to write 7 by 2. If you want to complete this reaction, the whole reaction must be multiplied with 2. Then what we get? 2C2H6 plus 7 by 2 into 2 will become 7. 7O2 on heating gives 4CO2 plus 6H2O. In this way, you can balance the combustion. Okay. Hope everybody understood this. Next important reaction in alkanes is substitution reaction. As we have studied, saturated compounds will show only substitution reaction. Example, methane if you take. So we have to understand one point, that if there are 4 hydrogens, we are going to get 4 products. Right. So let us take methane. So methane plus Cl2 in presence of diffused sunlight. So what is meant by diffuse sunlight means you have to use one small curtain or something. So less intensity diffuse sunlight, H nu. What happens? Substitution, hydrogen is replaced with the chlorine. So we get the product like this. So write CH3 as it is, and the new one chlorine atom you write it with red. So this is called as chloromethane. This is your first product. Now consider that other H is being substituted with the chlorine under the same condition. So what you get? Second product, this H is being substituted with this Cl. So we can write hydrogens in black, new added atom chlorine in red. So this is called as dichloromethane. Still we have 2 more hydrogens. So on addition of Cl2 again, what will happen? This H is been substituted with chlorine. So the third product what we are going to get, we have this is Cl, here also you are going to get Cl and this is Cl. So we are going to have trichloromethane. Trichloromethane, CHCl3, common name is chloroform. Now the last hydrogen is also substituted, so with the Cl, so we can remove this and get the final product. So what is the final product? So all Cl substituted, no more substitution occurs, and this is called as tetrachloromethane. Common name is carbon tetrachloride. So hope everybody is clear with these reactions. So next class we can continue with alkenes and alkynes. Thank you so much.